Okay, that will be much more efficient for me. So I won't be checking whether there are people trying to join. Let's wait for 1 minute or so before we have more students here. And let me share my screen first. All right, so I will just go ahead and start. Firstly, I would like to briefly talk about the first midterm, and I drew a score distribution here. And as you can see, a lot of you are doing pretty well. And I also provided the answer key here. So you can just click this link to download the answer key. And let me try to explain some of the common mistakes and also tell you what the score means typically. Some of you are asking about the grading scale. I'm not quite sure what the final grading scale will be, but I can tell you what the grading scale will be like approximately according to my experience in the past few quarters with the professor. And basically, from this graph, okay, so if you are above 54, then which means you get an percentage of above 90%. And according to my experience, eventually, if your overall score is above 90%, then you will get a GPA of 3.7 or above. And there's definitely no limitation to the number of students who can get a GPA of above 3.7 because we do not curve your grades. So we're not grading on a curve, we are grading on a scale. So which means you will not be punished by students who do better than you. You just need to do, better compared to yourself. So if you will be able to get an overall score of 90%, you will get a very decent score. So just try harder. So for students who are here, just if you try slightly harder, you can get a very good grade. And for students here, don't be discouraged. This exam is only 20% of your total grade. So you still have a lot of chances to get a decent grade at the end, as long as you do well in the following exams. I would like to briefly talk about some common problems, some common mistakes in the exam. I think the first question, yeah, so definitely a lot of you made mistakes in the first question. And actually this question is not intended to be a hard question, but still a lot of you are losing points from this question. The reason is some of you might forget about like what we talked about at the very beginning of the quarter. We did the math review, and this question is actually a math review question. Actually, in the professor's recording, I think the lecture 1, he actually talked about these type of constraints, right? We encounter in general, and also like the meaning of the Lagrange multiplier in general. And you just have to answer this question in the general context, okay, instead of under consumer theory. And actually this method will be used in the second half of the quarter as well. So it's really not context specific. And question 3 is also straight from the professor's recording. If you watch lecture 5, then you can actually just copy and paste what the professor wrote. Okay, so it's not really hard. But for question 2, I would say it's slightly harder, but it's still short questions. So you really don't need to write a lot, but still you need to write those essential steps. And I think the harder part of this question is to know what total differential is. We actually talked about this in math review as well. So you just need to know what's the total differential of P times Q. Okay, the total differential of P times Q is the partial derivative of this whole thing with respect to P times dP plus the partial derivative of this whole thing with respect to Q times dQ. And then the partial derivative of P times Q with respect to P is just Q, all right? And here we have P. So this is the first equation that you need to give. And then the second one is to divide both sides by P times Q, because you are asked to show the percentage change, right? So you have to convert this to percentage change. So if you divide both sides by P times Q, you will get, okay, the percentage change of P times Q, which is the percentage change in total expenditure or total revenue in the second half of the quarter, is equal to the percentage change of the price plus the percentage change of the quantity. And you just have to restate this assertion in the question, then you prove this assertion or statement. All right. Then I think the hardest question in this exam is question 4, but it's actually not too hard. So let me explain what you need to write to get full credits. A lot of you did get full credits, but how? So the first question is to draw the demand and supply curves and show the effect of the tax by shifting one of the curves. And because the tax is collected from the sellers, so you just shift the supply curve. But you have to notice that here we replace P by the natural log of P, and we replace Q by the natural log of Q. We talk about this type of demand and supply curves in the TA sessions. So you have to realize that they are the demand and supply curves with constant elasticities. So they are not linear, but then how to decide the shape of those curves. You don't have to do those calculations here. Okay, you can guess. A lot of you did guess the right one. But if you really want to understand why they are convex, then you can maybe do some calculation. You can rearrange the equation, convert the equation to an expression, okay, for P as a function of Q. So you just use these formulas here to help you finally get that P is equal to e to the power of 100, which is a constant, times Q to the power of -4. And then if you take the second derivative, okay, you will get a positive number, which means this demand curve is convex. And similarly, you can do the same for the supply curve, and you can see that second derivative is positive. So it's convex again. But you don't really need to do the calculations, because if you just check the textbook, they actually give you the conclusions. So if you go to the textbook and find the figure 2.10 and 2.11, they actually give you all the possible shapes of these type of demand and supply curves. And then you just need to figure out what the elasticities are. And I actually talked about how to see the elasticities right away from this equation. But one more thing about this is that here the price is on the left-hand side and the Q is on the right-hand side. But in the TA session, the Q is on the left-hand side while the price is on the right-hand side. So you really have to rearrange the equation first. Some of you did not, so some of you make mistakes. So you have to put the Q on the left-hand side and the P on the right-hand side. And then the coefficient of P will be the elasticity. So here the coefficient of P is -1/4. So it's gonna be -1/4 for elasticity of demand. And for elasticity of supply, because the coefficient of log P is 1/2, so the elasticity of supply is 1/2. You don't have to, do a lot of calculations. Some people try to, overcomplicate the calculation steps, but it's not really necessary. And finally, for the tax incidence on consumers or buyers, you just apply this formula. We talked about this formula in the TA session. Once you know the elasticities, just plug them in to your equation, then you get 2/3. So tax incidence on sellers is 1/3, which is smaller than 2/3. So buyers incur the larger tax burden. So although I wrote a lot here, but you don't have to show all those calculation steps. You just need to show the right shape of the demand and supply curves. And here, you should notice that without the tax, the supply curve starts from the origin. And then with the tax, it moves up a little, not much because it's a very small tax. So we're trying to calculate elasticity here, but because it's very small, we ignore this tax. And I don't want to show you more calculation steps. If you have this equation and you try to calculate the elasticity, it's slightly different from 1/2. But because tau is very small, eventually you will be able to cancel out a few terms approximately to get 1/2. So I'm not going to show you that. All right, so this is the hardest question in this exam, but surprisingly, there are a lot of students who get full credit, and more students are actually making mistakes in the first and the third question, the conceptual questions. And the last question is exactly what I talked about in the week 3's TA session. It's about perfect complements. So if you consume in a proportion of 4:1, then you have x equals 4y. And then the utility function will be the mean of x and 4y. And at this point, x equals 4y, it's the vertex of the indifference curve. So it's not differentiable. So you just answer no. And the graphs, all right. So as I said, you have to take some lessons from version 1 of the practice midterm 1. Although that practice exam is really hard, but they do ask similar questions. They ask you to draw an indifference map. By saying map, it means that you have to show a few indifference curves, right? It's not asking you to draw an indifference curve, it's asking you to draw an indifference map. So you have to show a few more indifference curves to show the dynamics of the indifference curves, how it moves, and what are the characteristics of the whole map. So clearly the vertex will be on this x equals 4y line, or y equals 1/4 x. So the vertex will be on this line. This is the first thing that you need to notice. And the second thing is if you check the values of those points, you will notice that the gap, the horizontal gap, is actually 4 times the vertical gap. So it's not something that you need to say. I would say the most important feature that you need to know is that those vertexes are on this line, and that's the most important thing. And you are drawing the right angles, and you are drawing a few more indifference curves. And finally, to get the optimal consumption bundle, it's not very hard. You have x equals 4y already given by this question. right? X equals 4y. You don't even need to, know what the utility function is. And then you have a budget equation, right? The budget equation says that the price of X, 1 times X, plus the price of Y, 2 times Y is equal to 24, your income or your budget. Then using these two equations, you should be able to get X and Y, okay, which are 16 and 4. So this is really all this midterm 1 is about. And we have another exam coming up next week. It's very soon, but you have to get used to it. This quarter, it's kind of like the pace is slightly faster than before because everything's online and you do have a lot of flexibility in learning. And we try not to make it too overwhelming, but we just want you to learn instead of, doing nothing at home. So let me try to share the screen of my iPad. All right, so seems that I have some technical issue here. Let me restart this app. And you can feel free to ask questions while I'm trying to synchronize my screen with my MacBook. Or you can just take a break.
I do actually have a quick question.
All right, please ask.
Just to clarify, the midterm next week is the last one, right? There's 2 in this class.
The midterm next week is going to be the last midterm, and actually the second exams of this course. We have 4 exams in total, so that will just be the second exam.
So what does that mean? The final is being split up into 2 parts as well?
Yes. So you have final part 1 and final part 2.
Okay, thank you.
You're welcome. I think I need to restart my iPad. So before the class, I actually successfully synced my screen of my iPad. But then because my iPad locked itself earlier, and then just suddenly I cannot. All right. So I'll briefly talk about today's plan. So we will talk about expenditure minimization, and we'll talk about the relationship between expenditure minimization with utility maximization. And then we'll talk about Slansky equation. And the coverage for the coverage of the second midterm is going to be chapters 3 and 4. We don't talk about chapter 5. So if I said that you need to read chapter 5, that's a mistake. Okay, so we don't cover chapter 5. So we only talk about chapter 1 to 4 before midterm, and then we will switch to production later after the midterm. And then after the midterm, there will be a new TA for you. So I will be gone, and Kwang Yu will replace me to be your TA. So for future questions after the midterm, you will need to ask him. Okay, you will send emails to him. And then for lecture recordings, you need to watch lecture 7 and 8. Okay, so now it's working. You have to watch lecture recordings 7 and 8 only. So I think the professor is going to upload lecture 9 or even 10 or more, but those are actually designed for the second half of the quarter. And then you also need to watch TA sessions 4 and 5. So this TA session is the 4th, and then next week we will have the 5th TA session, and then that will be all, okay? So this is the coverage, and the format of the second midterm is going to be pretty similar. So since you've taken the first exam, so you know what it is going to be. And again, we don't accept late exams. So if you can't attend the exam, just let me know first, and I will see what I can do. All right. So let me talk about today's topic. We will talk about expenditure minimization problem first. And what is expenditure minimization? So previously, we have a budget, and then we try to use the budget to maximize our happiness or utility or satisfaction. But what if we fix our satisfaction or happiness level? We want to find a way to achieve that satisfaction level using the minimal amount of money. Okay, so that will be expenditure minimization. And that's actually the dual problem of utility maximization. We are still trying to bang for the buck, okay? So they are sort of equivalent, but here we do not have any concern of the budget. You can spend as many as you want, but you just need to find the most efficient way to spend your money. And then you have a utility target or utility goal. You want to achieve a certain level of utility. That's why in this question, the constraint becomes that your utility should be greater or equal to a certain level. You want to achieve that at least, okay? But you don't want to spend too much. So you minimize the expenditure, and the expenditure, okay, is px times x plus py times y. That's originally actually in the budget constraint, right? So that would be the expenditure, and then the other side of that constraint is your income, but now we don't have any concern of your income. So this is the new problem that we want to solve. And to solve this minimization problem, we still use the Lagrangian method. So you just write the Lagrangian. It's equal to the objective function, right? Plus lambda times the constraint. But here, you have to be careful about which should be the one before the minus sign it should be the smaller one. Okay? The reason is you still want this to be a punisher of violation of the constraint, right? And lambda is positive. And to punish the violation, you want it to be larger when you violate the constraint. So let's see, if you violate this constraint, it means that U upper bar is larger than the utility function. So this term will be positive. So why is it punishing the objective? Because you want to minimize the Lagrangian now instead of maximizing the Lagrangian. So if you want to minimize this whole thing, then when you violate the constraint, you make it larger, which is not what you want. So by violating the constraint, you are being punished by getting a larger number. So we don't want to violate the constraint. So that's why we write it in this way. So that would be the Lagrangian for this problem, okay? The general form. And then you can minimize this Lagrangian by choosing x, y, and lambda. You just take the first derivative, partial derivative of the Lagrangian with respect to x, y, and lambda, and then you get a few equations. And then you use those equations to get x and y and lambda star. And here, the solutions to the EMP will be the Hicksian or compensated demands. And previously, in the utility maximization problem, the solutions are the Marshallian or uncompensated demands. Let's take a look at an example. So in these TA slides, I'm giving you an example of Cobb-Douglas utility function. Here, the utility function is x to the power of 0.3 times y to the power of 0.7. So we can write the expenditure minimization problem as this. And we can write out the Lagrangian following this standard procedure. And then we just take the partial derivative of the Lagrangian with respect to x, y, and lambda. And then we can rearrange those equations a little bit and see what we get. So we are still getting this equimarginal condition, which is the ratio of the marginal utilities is equal to the ratio of the prices. So that's the same equation that we get from UMP. Here we are still getting this equation. The reason is, okay, graphically at the optimal consumption bundle, the indifference curve and the budget line or expenditure line are tangent to each other. So we will always get this equation. But then the third equation is actually the binding constraint, which is saying that you want to achieve a utility level that's exactly, the lower bound, the goal, the minimum goal. The reason is to achieve a higher utility level, you need to spend more. And here you are trying to spend as little as possible. So you just want to barely achieve your satisfaction level. And that's why it's an equality. And then combining this equation with this, you will be able to solve for x and y. And you can see that because this constraint is nonlinear, it's not any linear equation. So your solution will be slightly more complicated. So you can try to do the math later. But basically, you just combine this equation with this equation. So here, for example, you can move this term to the right-hand side and then replace y by 0.7 px times x divided by py. And then here, I cancel out the 0 point. It's going to be the same. And then you can see that in this equation, you only have x. So just pull out X and then combine all the other things and then express X as a function of the prices and the utility level that you want to achieve. And that will be the Hicksian demand for X, and this will be the Hicksian demand for Y. So this is a shortcut. This is a graphical method. So unlike the previous one, the UMP, we are moving the indifference curve. Here we are fixing the indifference curve because we just want to achieve that utility level. We are moving, we are shifting the budget line. And here this is not actually budget line, it's actually expenditure line. You're moving this expenditure line up and down to find the lowest possible one that can support the indifference curve. And as you move the budget line or expenditure line downward, you will eventually find a point where the two curves are tangent to each other, and that will be our optimal solution. And you still get this MRS equals MRT. So this is the same equation. The only thing that is different here is that we do not have a budget equation, we have a utility equation. So the calculations are here. You are getting this as well. So I'm not going to talk about calculations, all right? I'm going to talk about ideas, and then you will do the calculations later. So why are they called compensated demands? The reason why we call them compensated demands is because we fix the utility level. Okay, so in the previous UMP problem, when we change the price of one good, they will have a different consumption bundle. But then their utility level is not necessarily the same as before, which means they may lose some purchasing power or they may gain some purchasing power, okay? If the price becomes lower, then they can buy more and then they will have a higher utility level, which means their purchasing power is higher than before. But if the price increases, then they will actually only be able to buy fewer things than before, then their utility level will actually be lower than before. Then they are losing some purchasing power. And we don't want that to happen here in this problem because we already fixed the utility level. So no matter how you change the price, they will eventually achieve a certain utility level, which means they will still have the same purchasing power as before, no matter how you change the price, because they can always buy things that can give them the same utility level. And we define purchasing power by that to achieve the same utility level. By doing so, we are actually compensating the loss or the gain of their purchasing power when the price is changing. And then it's only showing you the substitution effect instead of the income effect. So when we talk about demand curve in 200, we talk about income effect and substitution effect, right? When the price increases, you buy less. The reason for that is, one, your purchasing power is lower, right? When the price increases. So you tend to buy less if it is normal good. And then because it's more expensive than other goods, you substitute toward other good. You don't buy this one. So that will be the substitution effect, right? And here, because we fix your purchasing power, we fix your utility level, we are only focusing on the substitution effect. So I believe the professor already talked about expenditure function and indirect utility function. So basically, all right, so I will talk about this when we talk about the relationship between UMP and EMP. So let's go back to my iPad. So now we've talked about UMP utility maximization problem, and EMP, expenditure minimization problem. In the UMP, we try to maximize your utility while fixing your budget. And in EMP, we try to minimize your expenditure while fixing your utility target or goal. And then we solve the UMP and obtain X and Y star. That's actually the Marshallian demand or uncompensated demands here. So when you plug the Marshallian demand back into the utility function, you just plug the values of the Marshallian demands back into the utility function, then you get the indirect utility function or the value of the indirect utility function if you know what Px, Py, and W are. So W is your income here. We're using different notation. So W, you can replace W by I or another notation, but you know that it's income. And then you get indirect utility function, right? As a function of Px, Py, and your income. The reason is that the Marshallian demand functions are functions of Px, Py, and income. And in the expenditure minimization problem, when you solve for this problem, you obtain X and Y double star. We call them Hicksian demand functions. They are functions of the prices still, but also the functions of the utility level that you want to achieve. So it will be the U upper bar. And when you plug these Hicksian demand functions back into, okay, the objective function, the Px times X plus Py times Y, you just replace X and Y by the Hicksian demand functions. You will get expenditure function, all right? And the expenditure function will be a function of the prices and U upper bar. So how to link these two problems? So it happens that when the expenditure is equal to your income, you achieve the same consumption bundle. What do I mean? So here, if you, after doing this EMP, okay, you find that your expenditure happens to be the income here, then this U upper bar will be exactly equal to the final optimized utility that you achieve, which is the indirect utility function. So because of that, we can link these two problems, and then to get a Hicksian demand, we don't really need to solve for expenditure minimization problem. We can go from UMP. We can go from 1 to 2, and then to 4 and 3, instead of going from 3 to 4. And how to do that? How to obtain Hicksian demand without solving the expenditure minimization problem. The reason why we don't want to solve for EMP is because the constraint can be a little bit complicated. It can be nonlinear. And we are very familiar with UMP, right? So let's start from UMP. So the basic procedure is here. You just solve for UMP. You get Marshallian or uncompensated demands, X star and Y star, and you plug them into the utility function. That will be the first step. And the second step is, so from the first step, you get indirect utility function, right? And in the second step, just replace the income here, replace the W by E, okay, a notation for expenditure. And then replace, and then set this indirect utility function to a constant. And let's say this constant is U upper bar. And then you rearrange this equation, you take out the E, and then move everything else to one side, the other side. then you will get an expression for the E, and that's exactly the expenditure function. And that's how you go from 2 to 4. And once you get 4, the expenditure function, there are 2 ways for you to get the Hicksian demand. One is the method B, which is talked about by the professor. You just replace income by the expenditure function in the Marshallian demands, all right? And then you will instantly get Hicksian demands. The reason is here, when we replace income by that expenditure, we are fixing the utility. We're fixing your purchasing power. Or we can use a theorem, or actually a lemma, the Schaeffer's lemma. The Schaeffer's lemma tells us that when you take a partial derivative of the expenditure function with respect to the price of X, for example, you get a Hicksian demand for X. And then when you take a partial derivative of the expenditure function with respect to the price of Y, you get the Hicksian demand for Y. Let's take a look at the example that I gave you in the slides. So again, you have the same utility function, which is the Cobb-Douglas utility function, x to the power of 0.3, y to the power of 0.7. And we know the solutions to that UMP, right? You will spend 30% of your income on X, and then 70% of your income on Y. And then to get amounts of X and Y, just divide the income, the portion of the income that you spend on those goods by the prices of those goods. And then that will be the solutions to the UMP. So you know this right away, all right? And then to get the indirect utility function, you just replace the X and Y by the 2 Marshallian demand functions. So previously it's X to the power of 0.3, Y to the power of 0.7. But now you replace the X by X star, replace the Y by Y star, and then you can kind of rearrange this equation. So because it's the denominator, so it will get a negative sign before the exponent. And then this I to the power of 0.3 and I to the power of 0.7, you can combine these two and then you get I, okay? When you take the I out, you get I to the power of 0.3. When you take this I out, you get I to the power of 0.7. And when you combine them, it's I to the power of 0.3 plus 0.7, and then it's I to the power of 1, and it's I. And here you have 0.3 to the power of 0.3, 0.7 to the power of 0.7. So that's the net. That's actually the first step to get an indirect utility function. And then the second step is to replace this I here by E, expenditure, and then set this whole thing to a constant, which is U upper bar. So now let's say you want to achieve this level of utility, then what's the expenditure? All right, so now you have expenditure, you have U upper bar and the prices. You just rearrange this equation, just leave the E on one side and then move all the terms to the other side and combine with this U upper bar. So if you move the Px to the power of negative 0.3 to the left-hand side, it becomes Px to the power of 0.3. So the negative sign is gone. But then if you move 0.3 to the power of 0.3 to the left-hand side, it becomes 0.3 to the power of negative 0.3. So that's the expenditure function that you get. All right, that's the second step. And the final step is to get the Hicksian demand function for good X or good Y. Let's talk about the Hicksian demand for good X. So it's equal to the derivative partial derivative of the expenditure function with respect to the price of X, and then just use the power rule, take down 0.3, when you take down 0.3, you combine the 0.3 to the power of 1 with 0.3 to the power of negative 0.3, and then it becomes 0.3 to the power of 0.7. And then you subtract 1 from 0.3, so it becomes negative 0.7. Right, so it's here. So this 0.3 and this one, when you combine these two, you get this. And then because you subtract 1 from 0.3, you get negative 0.7. And then you can rewrite this as a ratio and then just put the 0.7 as the exponent of the whole ratio. You can do that. And then you can get a Hicksian demand function, which is exactly the same as what we got before, right? So when we solve the EMP directly, we also get this equation. So this proves our point, okay? You can get a Hicksian demand by going from the UMP to expenditure function and then use the lemma to get this. Or you can solve the EMP directly. So you have two ways to achieve the same goal using the relationship between EMP and UMP. So finally, I would like to talk about the Slutsky equation. So for the record, the derivation of this Slutsky equation is not required, but I still want to talk about this to give you an idea of how we obtain this equation and how you should feel safe to use this equation. So this starts from the method B, okay, of the last step. We use the relationship between EMP and UMP to find the equivalence. So basically, if you replace income by the expenditure in the Marshallian demand, you get a Hicksian demand, right? So you have this equation here, the first line. So once you have this equation, you can take a derivative of both sides with respect to the price of X. So when you take the partial derivative of both sides with respect to the price of X, you will be able to get, okay, on the left-hand side, it will be the derivative of dx with respect to px, which is the first term of this equation. And then because in the third term here, the expenditure function, you also have px. So you have to use the chain rule because for the third term, it's a function of the function. So by applying the chain rule, you take the derivative of the demand, Marshallian demand function with respect to income, okay, because that's the third term is about, multiply by the derivative of income, but we replace income by the expenditure now. So the derivative of the expenditure with respect to the price. So this is exactly from the chain rule. And because you have two terms that are related to px, that's why you have two terms when you take the partial derivative. And the right-hand side is just the partial derivative of the Hicksian demand function with respect to the first term. Then you can plug in u upper bar equals the utility function. You can replace all the u upper bar in this expression by the utility function, so we are not dealing with u upper bar. So if you do that, then on the left-hand side, the hx becomes dx. So when the utility goal is equal to the utility function, then the Hicksian demand becomes the Marshallian demand. And on the right-hand side, we just leave it as it is. So after rearranging this equation, okay, for example, you move the second term on the left-hand side to the right-hand side, then you add a negative sign. And I will tell you, this will be the final equation that you need to remember and the equation that you need to use in the exam. This is the Slutsky equation. So what is this about? It's about how to decompose the total effect of an increase in the price into income effect and substitution effect. And that's what I talked about earlier when we discussed why is Hicksian demand compensated demand. Because for Hicksian demand, we are only focusing on the substitution effect. But for Marshallian demand, we focus on the total effect, which includes the income effect. All right. So I also here, we have the Slutsky equation in terms of elasticities, but again, this is not required. So I will leave it as a reading for you. So I will upload this TA appendix for you to read. Hopefully I provide enough steps for you. I think this equation may be used in the homework, but not in the exam. So if you just want to do well in the exam, just remember this last equation here and know what each term is about, and that's all. You don't even need to know how to derive it. So I think that's all for today's TA session. Any question?
Yeah, question.
Mm-hmm.
So you were talking about how Hicksian demand is compensated, but I was a little confused what you meant by like compensated for what?
Compensated for example, if the price increases, right, in this equation. So if the price of X increases, then you will buy less X and Y because now in general, the price is higher. So if you are using the same amount of money to buy things, you can just buy less, right? So you are losing some purchasing power. And because you can buy less of everything, then your utility will be lower than before if you're not getting compensated, right? So if we do not give you some extra money to compensate the loss of your purchasing power due to higher prices, then you're losing utility, you're losing purchasing power, right? And by saying compensated demand, we want you to have the same ability to be as happy as before. So it's like we are giving you some money to help you achieve the same happiness as before. So by doing so, we fix your utility level, all right? So by fixing your utility level, it's actually compensating the loss of your purchasing power, right? And then that's why we call it compensated demand.
Okay, thank you.
All right, you're welcome. So it's the end of the class. If you do not have questions, you can leave. And if you have some quick questions, you can just ask right now. And I will stay for a few minutes and see if you have questions.
Hey, I have a question actually.
Mm-hmm.
Do you think we can go back to, I think what confuses me the most about this is the plugging of E into the dx at the top there. So
this one?
Yeah. So I think it's hard for me to like visualize because like we do a lot of this like equation writing, but we only kind of briefly touched on the application process. Like, do you think you can walk through that whole thing again?
Let me think how to visualize this. It's really not easy to like visualize this. I think in the textbook they have a few graphs, but I don't think they have a graph for this equation. But the idea is you want to link these two problems. And when will these two problems give you the same answer? So,
oh yeah, it's when their expenditure is equal to income, right?
Yeah, you want to make sure that these two give you the same answer, which means the Marshallian demand is equal to Hicksian demand. And that only happens when the expenditure is equal to the income. So the expenditure in the EMP is equal to the income in the UMP. So that's what we are doing. We are replacing the W, the income, by the expenditure function here. All right? So that's what we are doing. We are trying to find the equivalence. And by doing so, they are equal, okay? The Marshallian demand is equal to the Hicksian demand. And start from there, we can do all these derivations, but again, it's not required. But I think what is required is that you know this equation, because you may want to get the Hicksian demand function after getting the Marshallian demand function, right? So if you get a Marshallian demand functions, you get indirect utility function, and then you do some rearrangement to get expenditure function. Then to get Hicksian demand, you just replace the income in the Marshallian demand by the expenditure function.
All right, thank you.
All right, you're welcome. So maybe one more question? Anyone? The last question? All right, so if you do not have questions, I will end this session and just do the homework, just read the materials and get ready for next week's exam. We have an office hour on Monday and also on Wednesday afternoon. So 2 TA office hours next week. And then the last TA session by me next week. I basically will talk about the last topic for the midterm, and I will give you a midterm review for the next exam. And that will be it, okay?
I had a quick question. I was wondering, will the second midterm cover anything from the first midterm chapter 3 part?
It's not designed to be cumulative. So it will mainly based on this week and next week.
All right.
So it may come a little, so like a little bit of the content may come from last week, week 3. The reason is chapter 3 and chapter 4 are highly related. So it's hard to avoid chapter 3 completely. And as I said, chapter 3 is also in the coverage. So you still need to remember how to solve for the UMP, especially for Cobb-Douglas utility function. So the utility function that you will see in the second midterm is very likely to be Cobb-Douglas. So just get familiar with Cobb-Douglas.
Okay, got it. Thank you.
All right, I think this is the end of I will end this meeting.
Sorry, just one really quick thing.
Okay, yeah.
What should we read? What's the rest of chapter 4 covered in the textbook? Should we read like 4.4, 4.5?
You don't need to read 4.4, I think. Let me take a look.
Does that mean the extent of the material of the second part of the midterm is just parts 4 through 4.1, 4.3?
So you need to read chapter 3.1 to 3.4. And then you need to read chapter 4.1, 4.2, 4.3, and 4.5. So not 4.4. And then not 3.5.
Okay, thank you. That clarifies it.
All right. All right, I will see you guys next week.
Thank you.
Goodbye.
Bye.